Okay, question 7. We want to identify the independent and dependent variables, quantities, and then match up the scenario with each graph. On number 7, the first one, Madison is biking for exercise. Each Saturday she bikes a course she has mapped out around her town. She averages a speed of 12 miles per hour on her journey. Okay, so there is my key right there. 12 miles per hour. For every hour, she can bike 12 miles. So what that means is my independent quantity is time. If I see time, more than likely, that's going to be my independent. Dependent, that is how far you're biking. That's my distance, which in this case is in terms of miles. Now, based off what's happening there, you're biking and going a further distance as the hours pass. You're traveling at an average speed, a constant speed of 12 miles per hour. And the only graph that appears to be doing that is going to be letter C. Now, both B and C are increasing, but B is increasing a little bit faster than what C is. C is staying constant. So this is going to be graph C. They would like us to also label each axis. The independent, that is your domain. In this case, this is my hours, my time. And then this is my distance, which is in terms of miles. And typically, time is of the x-axis. Jermaine here is saving money to purchase a used car. He places $850 in a savings account that earns 1.65% interest annually. So he's putting money into account, and interest in this regard is helping you out earn money. So if you put things into a savings account, that savings account will slowly earn you some money, not at that rate. So here, that income is going up. So this is going to match up with graph B. Now, what is occurring here? Time goes on and Jermaine earns money. So we're going to call that independent as time as it goes on. And we'll go with that yearly. And what are we doing? We're earning interest. Interest is just money, and that is in terms of dollars. Oops. So time, again, is usually going to be your x-axis, your independent. In this case, money, my interest, is going to be my y-axis. Now, process elimination says this is going to be graph A, which makes sense. Marcus throws a football straight up into the air. After it reaches its maximum height, it goes 20 feet down and descends. So it increases and then it decreases. So as it increases, time goes by, and we're talking not minutes, we're not even talking hours, we're just talking seconds. And as it goes up, we're talking about height of a football, which is in terms of feet. Time, again, typically is always going to be that, and height right here, okay? So it goes up, here's where it reaches its max, and then it goes down. Oops, there's that.